right. We've been studying exponential functions at this point, and one thing we want to bring kind of to the forefront is how to solve some of these equations. Now, we're going to need kind of a more technical way to solve kind of the more tricky ones, but one way you can easily solve an exponential function is if you can get lucky and go ahead and find what we call an equal base. So looking at our functions down below here, 243 is equal to 3 to a power. Well, the one thing that I know about 243 is that that is 3 to the 5th. You can feel free to double check that on your calculator. But if I swap out 243 for 3 to the 5th power, what that gives me is an easy way to solve this equation. By basic logic, if 3 to a 5th power is equal to 3 to the x plus 1 power, well, then I can just cancel away those bases, right? They don't really mean that much because if they have equal bases with equal exponents, the exponents need to be equal to each other. And if I just subtract 1 over to the other side real quick here, we'll find out very quickly that x equals 4. 3 to the 4 plus 1, 3 to the 5th power, would have been 243. Well, let's do that same thing over here at the right. Now, this is going to be a little bit harder because 1/2 to a power, I'm thinking I would just continually get fractions, right? If I use positive exponents to the first, to the second, to the third, I'm going to keep getting smaller and smaller. Think exponential decay numbers. But if I want 1/2 to become a whole number, I need to flip it over. So I'm going to go ahead and flip this. I'm going to say that 1/2 is really 2 to the negative 1. And in that case, well, hey, I know that 8 is really 2 to the 3rd. And just like we did on that first example, that means I've got 2 to the power on both sides. Now, I do need to clean it up a little bit. If you remember, when you take power to a power, we typically multiply. So this is going to be 2 to the negative x is equal to 2 to the 3rd. But now I get those equal bases, right? I got those 2's going there, which means that negative x, equal bases equal to each other, means that the exponents need to be equal. And a quick little divide by negative 1, and we'll find out that x equals negative 3. And again, we could always verify that. 1/2 to the negative 3rd power. Negative is going to flip it over. That makes that 2 to the 3rd, and 2 to the 3rd is definitely 8. Again, I hope that helps you. By the way, that's called using the one-to-one property in our Precalc book here. So just note to self, if they ask you to use the one-to-one property, they're saying, can you find equal bases? Use equal bases to go ahead and solve equations. I hope that helps you solving equations. Again, we'll get to some more technical solving in chapters down the road. But otherwise, talk to your teacher if you have any questions, and have a great day.